the derivative, we talked about the slope of the straight line and generalize it to a slope of a curve at a point, at a certain point. And from that definition, we make the definition of the derivative. We know how to take the derivative and differentiate some functions. Today we will complete, we will use the limits to define other rules for the derivatives. We will take these rules and we will take some applications, especially the rate of change. This was the straight line. Take the slope of the straight line. A line and how to graph a line in the plane using either slope and a point or using 2 points. I think take all the derivatives dubbed here. That's what the last example we talked in the previous lecture. Now let's take this example to review what we talked in the previous lecture. The question is, find the equation of the tangent line, which is a straight line, to the graph f of x. This is the function, the given function, at this point. This is the point that I want to find the tangent line, the slope of the tangent line, or the equation of the tangent line at it, which is x equal to 4. As we said, the equation of the tangent line or any line, I take it from the slope equals change in y minus y1, for example, over change on x minus x1. Okay, where can I get the m, which is the slope? The slope for any graph, tangent line, or for a graph at a certain point, I find it using f dash of x. Okay, and substitute with this x with x equals 4. So here I will find f dash of 4. So first, I need the slope. So I will find f dash of 4. First, f dash of x equals, this is f of x. When I differentiate 3x is actually a linear function. This is a line. When I differentiate 3x, this is x to the power 1. So it will be only 3. The derivative of 3x is only 3. If I differentiate x, the derivative will be 1. So only 3. Okay. When I substitute f dash of 4 in this function, this is actually a constant. There is no variables to replace. So even if I substitute with 4, the result will remain 3. Okay, I don't have any variable here to substitute or replace. So the result will be the same for any value, either if it's 4 or any other value. Will be 3 for all values of x. Okay. So this is the slope. Okay. Now I need another point, a point actually. I have here x equals to 4. So I need only the y coordinate. Okay. In the plane, when I have a point, I need x1 and y1. I here have x1 given, for example, here given 4, and I will use f to find y1. So here for x equals 4, f of 4, notice here, not f dash of 4, f of 4. I want to find the coordinate for a point in the plane. الغرض هنا إيجاد إحداثيات نقطة في المستوى، مش المشتقة ولا الميل. فأرجع أعوض في الدالة الأصلية. So it will be 3 multiplied by 4. Okay. I substitute here 3x, which is 12. So I have a point which is 4 and 12. Now I can make the equation of the tangent line. This is the tangent line. I have a slope and I have y coordinate and I have a value of x coordinate. I have x1, y1 and m. M, as I said, is f dash of 4, which is constant here, constant, which is 3 equals to y minus 12 over x minus 4, which is y minus 12 equals to 3 multiplied by x minus 4. And complete, of course, to simplify until I reach the value or the equation y equals to some value m. Let's call it here m1, for example, mx plus b. Or let's say here a. Not be confused with the slope of the tangent line. Okay. Here y minus 12 equals to 3x minus 12. Of course, I can omit here minus 12 minus 12, so y equals to 3x. I notice that the slope of this tangent line is also 3. Okay. So the solution here is 3x. Notice that it's the same of the function. The graph of this function is actually a line, so the tangent is the same function f of x. هذه دالة خط مستقيم، فالخط المماس هو أساسا خط ينطبق على الدالة نفسها، فعشان كده طلعت لنفس الدالة. لو كانت مثلا 3x square it will be different here. But I obtain a same line since it's already a line or a linear function. Okay. Now for some notations, بعض الرموز المستخدمة للاشتقاق. Here we said that I can write f dash of x as a derivative, and also I can use this notation d by dx of f. Okay, so it's equivalent to say d by dx for f of x, and it's also equivalent to say that it's y dash. Okay, I can just make a notation for the function y, and the derivative will be y dash, and it's equivalent to say dy by dx. So I'm here, take the derivative with respect to the value of x. I only take the derivative of x. This is the definition, the derivative with respect to x. Okay, so when I see this notation d by dx for any function, I already take immediately take the derivative, differentiate. Okay, and also dy by dx. The question is to differentiate. Now we will use the main definition of the differentiation, which is using the limit. Okay, first, to know what is this notation, suppose that you have a graph here, a graph for any function in the plane, and you have here 2 points. Let's say that I have here 2 points. Okay, This point, the first one, for example, it have x as an x coordinate, and of course this is the y coordinate. Here the value is f of x, okay, f of x or y. How can I get y? It's the value of the function f when I substitute of x, okay. This is the value of this point, which is x and f of x, okay. And this point, the second point, if I want to find the x value here, it's far from x by this distance, right? This distance could be, for example, just a moment, a space measured by h. The measurement of this space, the length is h. So this value will be x plus h. I move to the right h unit. Okay, so if this is x plus h. Okay, since this is the x coordinate for this point, the y coordinate here will be f of x plus h, like this. Okay, this is the x coordinate. I substitute in the function by this value to find the y coordinate. So this is the place between these 2 points. Okay, now to find the slope of the tangent line between these two points, I will take the rate of change in y. The top, I will take the change in y, and I will divide it by the change in x. Okay, the change in y will be like this: f of x plus h minus, this is the change in y, difference between y1 minus y2, or y2 minus y1, minus f of x divided by the difference in x, or the change in x. So here, the bigger number or greater number here is x plus h minus x. Okay, so I have here x minus x. It will delete together, and I will have f of x plus h minus f of x divided by h. Okay, so I have here a quotient. This is a quotient, عملية قسمة. This is actually the main definition of the derivative. The derivative is actually a rate of change. I divide the change in y over the change of x, so it's a rate of change. Okay, if I take these values, I have this quotient, and if I have this distance very small, it could be even 0, I will have the derivative f dash of x. So the f dash of x is defined by the rate of change f of x plus h minus f of x divided by h. When h approaches to 0, I take h very small until it approaches to 0. So I take here the limit when h approaches to 0. This is the definition of a limit. And this is the main definition of the derivative. Okay, we will take some applications, of course, to find this derivative using this definition. In the exam, if the question is use the definition to find the derivative, you have to use this definition. You don't have to apply the rule immediately. You have to use this definition first if the question was use the definition. Okay, we will take, of course, some example to know how to use this definition and how to take the limit. taking the limit when h approaches to 0 is actually only substitute this h with 0. Of course, I can't here substitute immediately since I will have a 0 in the denominator. It's undefined. But with simplification, if I simplify, I will have a defined value. Okay. This is actually the definition how to differentiate the derivative. This is an example. I will apply this definition. Okay, I will apply this definition. The question will not be applied 3 steps method. The question will be use the definition. Use definition to find f dash of x. Okay, and f of x is defined by this function. So I will begin with this definition, f dash of x equals to limit. I will keep the limit in each step until substituting h by 0. Okay, here first I will substitute in f by x plus h. So here only this x, I will replace it by x plus h. Okay, I will find this first, then I will put minus f of x. So I have here minus, instead of x squared, here plus 2, instead of x, I will take x plus h. So only x replaced. Minus, here minus, f of x, taking the same function given, okay, divided by h. So here, what did I do with this? We take, notice here, I'll replace this x by x plus h to find this, which is f of x plus h. Then minus, this is minus, f of x, this is f of x. Okay, this is f of x, and all of this is f of x plus h. Okay, now I simplify. Okay, I distribute and get rid of all these brackets. Okay, now it's equals to, I'll complete here, limit, keep limit in each step, limit h equals to 0, equals to, here, before the sign here, notice here that the square is not on the sign, it's only inside this, only x plus h is squared, not the sign, so I will keep the sign. Okay, I will take now the square of this value, it will be x squared plus 2xh plus h square. Okay, this is how to write the square of the sum, plus 2. Okay, minus, now I will take this minus and distribute it inside this brackets. So minus x will be plus x squared minus 2. I just distribute this sign, negative sign, inside the brackets. There's no other simplification inside it. Divided by h equals to limit h approach to 0. Now I will distribute this sign inside this brackets. So it will be minus x squared minus 2xh minus h squared plus 2 plus x squared minus 2 over h. Notice here that I can simplify before I complete. I have here minus 2 with the plus 2. I can omit it together. And also I have minus x squared and plus x squared. I will omit it together. This is the remaining value. So I will complete limit when h approaches to 0 of minus 2xh minus h squared divided by h. Notice here in the top, in the numerator, I have h in the both terms, so I can take h as a common factor. So here equals to limit h as a common factor multiplied by minus 2x minus h. Okay, I take this h out and one of these two h out as a common factor, divided by h when h approaches to 0. Here I can omit. Notice here, since I take h as a common factor, it's multiplied. Here, two multiplication together, so I can omit from the top and from the bottom 1h. So this will be equal to, now I can take the limit after simplification. It will be the limit of minus 2x minus h when h approaches to 0. Now I will take the limit. Since I omit the h from the numerator, I can take the limit. مجرد اني اتخلص من ال h اللي موجوده في المقام، اقدر اني اخذ الليمت بالتعويض عن h تساوي 0. This will be minus 2x minus 0. I will substitute h by 0. Okay, so the result will be equals minus 2x. This is the value of f dash of x, and this is actually expected, since I have by the rules f here, this is the value of x, of f of x, sorry. I have that f of x given by minus x squared plus 2. When I take the derivative using the rule or the power rule, it will be, I will just take this down, minus f dash here. It will be minus 2 multiplied by x to the power 1, which is 2 minus 1. And the derivative of 2 is 0, so this is the derivative. So my result here is true. I will use the definition to find the same result using the power rule. Okay? In the exam, as we said, if the question was use definition to find f dash, you have to do all these steps. Do not write the final answer. Okay? Okay, this is the steps in the slide, and this is another example. This is how to write the question, or how to find the question in the exam. Use the definition of the derivative to compute the derivative f dash of x. So the question is to find f dash of x using the definition. This is the given function, which is a quotient, a rational function, دالة كسرية. We will use this definition to find its derivative. Okay, so I will take the definition. F dash of x equals to limit when h equals to 0. We will keep the limit in each step. Limit. Now we will substitute in this function f by x plus h. Instead of x, we will write x plus h. So 1 over 2 multiplied by x plus h plus 5. Okay, this is f of x plus h. X plus h. Then minus f minus f of x, which is the same function, minus 1 over 2x plus 5. Okay, all divided by h. All these in the numerator. So now I will complete here. Limit from h when h approaches to 0. Of course, we have to simplify this. Okay. Here I have 2x plus 2h plus 5, and here 1 minus 1 over 2x plus h. I have here to unify this denominator. نحتاج إلى توحيد المقامات. Limit. Here a big quotient all divided by h, and the common numerator will be 2x plus 2h plus 5 multiplied by 2x plus 5. I will just multiply these denominators together. And here, instead of this one, I will multiply 1 by 2x plus 5 minus, so this will be minus, this is the minus, 1 multiplied by this, which is 2x plus 2h plus 5. Okay. Here limit when h approaches to 0. Now also here limit when h approaches to 0. Here I can simplify this on the top. I can distribute this sign inside these brackets and omit some values. So I have here 2x minus 2x. It will be deleted together. I have here plus 5 minus 5. If I distribute this function, this will be minus. So plus 5 with minus 5. The only remaining value is minus 2h. So I write here minus 2h in the top, minus 2h divided by these two brackets, which is 2x plus 2h plus 5, and here 2x plus 5, all divided by h. Now I have here a big quotient. Okay, this is the main quotient. If I want to divide two rational numbers together, I multiply by the reciprocal. عملية قسمة الكسور معناتها أضرب في مقلوب المقام. So here I will complete here equals to limit when h approaches to 0, 1 over h, this is the reciprocal of h, مقلوب المقام, multiplied by minus 2h divided by these two brackets, which are 2x plus 2h plus 5, and here, sorry, okay, here 2x plus 5. Now I can omit these two h together. Okay, this is h from the numerator and h from the denominator. Okay, and there is nothing added together. ما عندي كميات مجموعة أو مطروحة مع بعض. هذه الواحد مضروبة في minus 2h. Okay, they are multiplied together. So I can omit this h with this h. So the last simplification will be limit when h approaches to 0 of minus 2, only minus 2 in the top, divided by 2x plus 2h plus 5 and 2x plus 5. I don't have to take the multiplication between these two, since I will substitute with this h with 0. It will be simplified later. Okay, now I omit this h, which was the problem in the denominator, so I can here substitute with h. I still have this h, but when I actually substitute with 0, it will be added with other values. So I won't have 0 in the denominator. It won't be a problem. Now I will take the limit minus 2 divided by 2x plus 2. Instead of h, I will take it 0 when I take the limit, plus 5 multiplied by, this is all multiplied by 2x plus 5. Okay, now after this multiplied by 0, it will be deleted. So minus 2 in the top and 2x plus 5 multiplied by 2x plus 5. This is the result. I notice here that these are the same inside the brackets, so I can just write it like minus 2 divided by 2x plus 5 square. This is the final result. Okay, when I take the limit and simplify, I finish the solution, and this is the derivative which is required in the question. Minus 2 divided by 2x plus 5 all square. This is actually the same result when I use the rules. Okay, if I want to use the rules without the definition, I will show you now how to use it. Here I have f of x is actually 2x plus 5 to the power minus 1. This is f, okay? To find the derivative, f dash of x, it will be minus 1, okay, multiplied by 2x plus 5 to the power minus 1 minus 1, okay? I will rewrite it here, minus 2 multiplied by 2x plus 5 to the power minus 1, which is minus 2. Okay, since this power is negative, so all these will be in the denominator. So here, minus 2 divided by 2x plus 5, all square. This is how to use the direct rule, and this is how to use the definition. من وين جبنا الباور minus 1؟ من الكسر. بشكل عام, in general, when I have 1 over x, it's the same when I said that x to the power minus 1. Okay? It's the same. I can rewrite any rational by a negative power. 1 over x, x is x to the power minus 1. And here, 1 over 2x plus 5, it's the same when we said 2x plus 5 to the power minus 1. أي شيء في المقام أقدر أرفع إلى البسط بأس سالب. هذه فقط طريقة الحل. Okay. The numerator here, minus 2, is a coefficient. هو عدد ثابت مضروب في الدالة. فهو يمشي من غير أي تغيير. يمشي مع الدالة في كل خطوة من غير أي تغيير. We'll take this rule later. لما حذفناه هنا minus 2. هذا هو minus 2. Minus 2, I take it from here. When I take this down, minus 1, I take it down. I don't omit minus 1. I take minus 1 minus 1, which is minus 2. Okay? Minus 2 with a negative sign in the power, so it's in the denominator. It's in the bottom here. Okay? This is how to differentiate irrational functions. This is the solution in the slide. Okay. Now we talk a polynomial, which was a squared, and we talk a rational. دالة كسرية. أخذنا دالة كسرية ودالة كثيرة حدود. It remains to find the derivative for a square root function, and this is the simplest one, which is the square root of x. جذر الإكس رح نوجد لها المشتقة باستخدام التعريف. We will use the definition of derivative to compute the derivative of square root of x. Okay, we will use the definition. So limit in each step when h approaches to 0 until I take rid of this denominator h. Okay, now it will be h in the denominator, and here f of x plus h, which is the square root of x plus h minus, this is the minus, f of x, which is the same function, square root of x. Okay, and the square root, since I here have square root minus square root, there's actually a method called multiplying by the conjugate، الضرب في المرافق، أو عملية انطاق الجذر أو انطاق المقام، كنا نسميها انطاق المقام أو انطاق الجذر. I will multiply by the conjugate. Since I here have a negative sign, I will multiply by this value in the top and the bottom, but with the different sign, like this. I will just multiply the top by the square root of x plus h plus square root of x divided by the same value, x plus h plus square root of x. Always when you have square roots, how to simplify things with the square roots, you use this conjugate method. Okay, here when I multiply the top and the bottom with the same value, the value will not be changed since I use the same value for the denominator and numerator together. So now it will be equals to limit when h equals to 0 for, here I have a direct rule, since the only difference here is this sign, it will be the first square x plus h. When I square the root, it will be omitted, so only what's inside the root, minus, okay, this is fixed, the second square root of x square, it will be omit the root, minus x. And in the bottom here, it will be h multiplied by square root of x plus h plus square root of x. Okay, I can here simplify. I can omit x with minus x. Only h will be remain. Limit when h approaches to 0 for h in the top and h in the bottom for square plus square, here x plus h and here x. Here also only h in the top can be omitted with this h. Notice here there's no sign between this h and this bracket. It multiplied. When it's multiplied, I can omit it with the top values. Okay, so this is the limit 1 instead of h. I omitted, so I replace it with 1 divided by x square root of x plus h plus square root of h. Now I take the limit. I omit the h, this h, the problem in the denominator, so I take the limit. Now take limit. It will be equal to 1 over square root of x plus 0 plus square root of x. Yes. Okay, that's right. So here I have 1 over square root of x plus square root of x. I have here two values. So 1 square root plus 1 square root, it will be 2 square roots. Okay, 1 over 2 square root of x. This is the value of the derivative. Okay, this is f dash of x. And this will be the same result when I use the power rule. Also, I have square root of x. As we said, the square root is actually a rational power. It's equivalent to, say, x to the power half. Remember this rule? I can rewrite the square root of x as x to the power half. So when I find f dash of x using the power rule derivative, it will be half multiplied by x to the power half minus 1. Okay? It will be 1 over 2 to the power x2. Half minus 1, it will be minus half. Okay? Minus half. If I want to simplify it, I have here a minus power. So it's in the denominator. So I keep 1 in the numerator. And here I will have 2 multiplied by x to the power half. Okay? I here again have x to the power half. So it's a square root. So it will be 1 over 2 multiplied by square root of x. This is how to use the rules to find the derivative of square root. And this is how to use the definition. Of course, this could be easier if you know how to rewrite the function and use the power rule. Okay? You can check your answer using definition by this rule. And this is the same answer. Okay. Okay, now for another example. This is the original slide. And this is similar to the first example. I have here a polynomial, a normal polynomial, x to the power 3. Now, how to use the definition for the power 3? It will be a little bit more complicated, but if you know what the simplification required, it will be easier for you. So this, of course, I'm talking here about f dash of x equals to limit when h approaches to 0 of the definition here divided all by h, the definition f of x plus h, which is 3 multiplied by x plus h all to the power 3 plus 2 multiplied by x, so x plus h, which is this, minus 1. This is f of x plus h. Now minus f of x, it will be the same function given, 3x squared, not square, cubed, plus 2x minus 1. Okay, now I simplify. So I have to take rid of this brackets. Okay, I will write the formula of the cube here equal to limit when h equal to 0 of, here I will have 3 here 3. Now I take the power to the power 3 for this value. It will be x to the power 3 plus 3 x square h. This is a rule of the cube of the sum of two values plus 3x. Now h square plus h to the power 3. Okay, this is how to make the cube of the addition x plus h. Then plus 2x plus 2h. I just distribute this 2 inside this bracket, minus 1. Now I will just distribute this sign inside this bracket. which will be minus 3x cubed minus 2x plus 1. Okay, all divided by h. Now I take this 3 inside the bracket and omit the equal values. So here I will have 3x squared and minus 3x squared. It will be omitted together. Okay, I will just distribute it in the same step. So 3x plus 9x squared plus 9x plus 3. Okay, and I just distribute 3 inside this brackets instead of rewriting for second time. So I omit minus 3x squared with plus 3x squared. And also, I don't have any other x squared and h squared, so I have here minus 1 with a plus 1. Minus 1 plus 1. And also I have plus 2x and minus 2x. This is only, okay, so I can here write the remaining. So it will be limit when h equals or approaches to 0 for, I have here 9x squared h plus 9x h squared plus 3h to the power 3 plus 2h. This is only remaining okay, this is the only remaining after the bracket, plus 2h divided by h. Okay, notice now I have here 4 terms and each term has an h, so I can take h as a common factor. Okay, limit when h approaches to 0, I take h from each term, so I have here 9x squared, I took this h, plus 9x h, I took only one h from here, plus 3h squared, I took only one h, plus 2 divided by h. I can omit now the h from the top with h from the bottom. So I omit this h. I can take the limit now. So now I will take the limit, apply the limit. It will be 9x squared. If I apply the limit, I don't write it. 9x squared plus 9x multiplied by h, so multiplied by 0, plus 3 0 squared plus 2. There is no denominator here. I omitted with h. So that will be equal to, this is multiplied by 0, will be deleted. Also, this is multiplied by 0, will be deleted. The only remaining result will be 9x squared plus 2. This is the final result, which is f dash of x. And it's the same result when I just differentiate this function using the power rule, f dash of x. I just multiply the 3 by 3 here, which is 9x to the power 3 minus 1 square, plus the derivative of 2x is only 2, minus 1, the derivative of a constant is 0. So this is the result using the power rule. Okay? And it's the same when you use the definition. You can check your answer using definition by the power rule. Okay, now for the example in the slide. For more rules. Now, if I have a function multiplied by a constant, okay? I have here, for example, f of x multiplied by a number, let's say it's k. هي أساسا هذه الطريقة استنتجناها باستخدام التعريف. التعريف هو أساسا الطريقة الأصلية. لازم تكون عارفة الطريقة الأصلية عشان تقدر تستنتج التعريف. Okay. You have to use it only when it's mentioned in the question. فقط لما يكون مطلوب في السؤال use the definition, you use the definition. But if the question just find the derivative or differentiate, use any rule you know. تستخدم القاعدة لما يكون مطلوب فقط المشتقة. فقط إذا كان مطلوب استخدام التعريف use the definition, you use the definition. Okay. Now, as we said, if the function multiplied by a constant, you just ignore the constant and differentiate the function. So take it outside and differentiate f. Okay, if k is a constant. For example, if I have 3 multiplied by x to the power 5, I just have 3 outside and differentiate x to the power 5, which is 5x to the power 4. Okay, then multiplied by this coefficient or constant, which is 15x to the power 4, for example. Okay, and also if I have another, let's say I have the function sine x. You don't have trigonometric now. It will be later in this course. If it was multiplied, for example, by 3, the derivative will be 3 cosine x. This is the derivative. This is just an example how to deal with coefficients. Also, the sum rule, if I have two functions added together, okay, the addition between these two functions, I just differentiate the first one plus the derivative of the second one. Okay, مشتقة الأولى زائد مشتقة الثانية immediately. Also, the power rule, if I have a function, let's say it's g of x, power taken to the power r. Okay, I first take the derivative of the power as a polynomial, then differentiate inside. I actually name this rule by chain rule. We will talk about it later in details. Chain rule. If I have a function inside a function, أشتق الدالة بشكل عام بعدين مشتقة ما بداخل الدالة. Multiply together. I just here differentiate the power, then differentiate what inside the power. Okay? For example, if I have this function here to the power half, and inside it I have x squared plus 1. If I want to differentiate this value, I first differentiate the half, here the power, so it will be half with the same function. Half minus 1 will be minus half like this, with the same function x squared plus 1. Then multiplied, here multiplied, with the derivative of x squared plus 1, which is 2x. This is the derivative of this function. Of course, we will take more examples about this. For example, this function, I have here f of x. I have in the numerator here a coefficient or a constant, 45, and in the denominator, I have 1 plus x plus square root of x. How to differentiate? Of course, here is the question is just differentiate. I don't have to use the definition. I just differentiate using the rules. Okay, I will use the rules, not the definition since it's not mentioned here. Okay, first I have here f dash of x. It will be, of course, this is only a constant. I will write it in each step until simplification. I will rewrite the function f here. Before taking the derivative, I will rewrite the function. أعيد كتابة الدالة عشان تسهلي الاشتقاق. Rewrite the function. This is equal to, say, 45 multiplied by the denominator 1 plus x plus square root of x to the power minus 1. Anything in the denominator, take it to the top with a negative sign, like this. Also here, a square root, I can rewrite it like this. Now I will change only the square root. It will be 1 plus x to the power half, all to the power minus 1. Okay, now I will take the derivative. It will be 45. I want to change this number until the final simplification, multiplied by. Now, I would first differentiate this power. So I will take it down here and multiply it by 45. So here it will be minus 45 multiplied by all what inside the brackets to the power minus 1 minus 1. Okay, 1 plus x to the power half. I didn't finish now. I have also to differentiate inside the bracket. So here multiplied by the derivative of this value. Okay, so the derivative is, derivative of 1 is 0, derivative of x is 1, plus derivative of x to the power half, as we said, it will be 1 over 2 multiplied by x to the power minus half. Okay, you can find it by details. This is equivalent or equals to minus 45 multiplied by 1 plus x to the power half, all to the power minus 2. And also here I can simplify 1 plus, I have here 1 over 2, this is 2, and I have here x to the power minus, so I will take it here x, and it's to the power half, so it will be a square root like this, and here 1. Okay. For more simplification, I have here minus 45. I have here minus in the power, so it will be in the denominator. All the bracket will be in the denominator, which is 1 plus x to the power half. I get it back to square root of x. Power minus 2 minus, take it to the bottom, and 2 will stay here. This is multiplied by 1 over 1 plus, sorry, here 1 multiplied by 1 plus 1 over 2 square root of x. Okay, I can here make more simplification. I can here unify the denominators. So 2x as a common denominator, and here 2 square root of x plus 1. وحدت المقامات في هذا القوس equals to here minus 45 multiplied by 2. هذه قاعدة القوى. ليش صار minus 1 من هنا؟ I want to differentiate this. I take this down and subtract 1 from the power. Minus 1. So the result will be minus 2. Okay. Here I just simplify here. Minus 90 minus 90 square root of x minus, I can keep it out or distribute it, divided by, here I have 2 square root of x multiplied by 1 plus x plus square root of x all square. This is maybe the final result, the simplest answer that we can get. Okay. It will be more complicated if I take the square root of all these three values, so I will keep it like this. Okay. And this is similar to the result here. Yes, it's the same with the slide, but here in the slide, instead of 1 over 2x, okay, they keep 0.5 in the top, and they didn't unify the denominator. هنا ما أجرى عملية توحيد مقامات. فممكن إنكم تخلوها عند هذه الخطوة. You can keep it like that, or you can simplify it more. Okay. Notice that it's the same result that we get. The same. Okay, but I unified the denominators here. So this is the simplest answer. Okay, now the same question, but in different way. The question is, find the points on the graph F at which the tangent line is horizontal. The tangent line is horizontal. If I have a graph, for example, like this, a graph, okay, there are some certain points, especially or specifically like this. It will be at the top or in the bottom of a graph. When I draw a tangent line like that, the tangent line will be horizontal. It's a horizontal line. Okay, this is the tangent. The tangent line. The question is, find the point, this point, that make the tangent line horizontal. There is actually a method to find this point, which is finding the derivative as we always did, then make the derivative equal to 0. So the steps that we will use is find the derivative f dash of x. I will find it. Then I will take the derivative that I find here and make it equal to 0 and solve the equation. If I solve the equation, I will have values of x. This value of x will be the point that makes the tangent horizontal. This is how to solve this question. Find the derivative, make it equal to 0, and solve it for x, and find the point. So first, I will take the derivative. Now I will find f dash of x. I have here a rational function, 1 over x cubed minus 12x plus 1. I can rewrite this function. So first I will rewrite the function f of x equals to x to the power 3 minus 12x plus 1 all to the power minus 1. So to find the derivative, f dash of x, I take this power down minus x to the power 3 minus 12x plus 1 all to the power minus 2, which is minus 1 minus 1. This is always how to differentiate. Okay. Equals to, of course, this is the final result. All what it remains is to get rid of this negative power. It will be minus 1. It will be multiplied by what inside the derivative what inside the brackets, which is 3x squared minus 12. Okay, so if I simplify it, it will be this minus multiplied by this bracket, 3x squared minus 12. I didn't write this in the top since it's with the negative sign. I will write it in the denominator, x cubed minus 12x plus 1 to the power 2. This is the final answer, the simplest answer. I can also distribute this this sign inside the brackets. Now, the second step is to find the derivative equal to 0. Okay, I will solve this equation. So I take this derivative that I found, minus 3x squared minus 12 over x cubed minus 12x plus 1 all square equals 0. Now, how to solve this rational equation? I multiplied here the scissor. When I multiplied this denominator by 0, it will be 0. So all the remaining is the top here. Immediately, I write the top, the numerator, minus 3x squared minus 12 equals 0. اوكي، لما يكون عندي بسط ومقام يساوي الصفر معناتها ان البسط يساوي الصفر. Why? I multiplied the denominator by 0 لاني راح اضرب هنا عملية المقص، راح يضرب المقام بالصفر ويحذف، اللي يبقى فقط البسط يساوي الصفر. This is the only equation that I have to solve. Of course, here I have minus equal to 0 dividing by minus 1. I will simplify it more here. 3x squared minus 12 equals to 0. I will move 12 to the other side, which is 3x squared equals to 12. Dividing by 3, it will be x squared equals to 4. The only remaining step is to take the square root. X equal to the square root of 4, which is 2, but with 2 signs, plus or minus 2. So I have 2 points, 2 x values that makes the tangent line horizontal. But this is only the x value. If I want to take the point, I need the y value. Okay, I need the y coordinate. Okay, this is the x coordinate. هذا فقط الإحداث السيني. أحتاج أيضا إلى الإحداث الصادي. So I find the y coordinate from the original function. Okay, now I will complete it here. For x equals 2 first, then x equal to minus 2. For x equals 2, f of 2 is 1 over 2 to the power 3 minus 12 multiplied by 2 plus 1, which is 1 over 8 minus 24 plus 1. Find this value, and also someone find this value. For x equals minus 2, f of minus 2 equals to 1 over minus 2 to the power 3 minus 12 multiplied by minus 2 plus 1. Okay, and also find the result. Minus 17, sure. 8 plus 1 is 9. 9 minus 24, it will be minus 1 over 24 ناقص 9 بكم؟ What is this number, 10 or 15? Okay, it will be 15, minus 1 over 15. And also here for -2, -1/15, okay? Okay, here also, I will complete it here. It will be 1/-8 minus, it will be +24 plus 1. Okay, this will be 1/25 minus 8. 25 minus 8, 1/1 over 17, right? 1/17. Okay, 17 or 16? 17. Yes, 17. Okay, so the points, just erase this. The required points, I find 2 points that make the tangent line horizontal. The first one is 2, which is here 2, and -1/15, and the second one is -2 and plus 1/17. Okay, this is the 2 points of the horizontal tangent line. Okay, this is the same result. Okay, now another example. We talked about the rate of change, and we said that the rate of change is the derivative. Of course, the rate of change at a point is the derivative at this point. Okay, and this is an example, an application. Okay, this example, let's just read it to find the meaning. Let S of X, this is a function, represent the total sales. So S is the function of sales in thousands of dollars. This is the unit of the measurement. For month X, so the value here of X is the month. Okay, if X equals 1, I'm talking about January. Okay, X equals 2, it's February. Okay, so the values, the possible values of X is from 1 until 12. This is the values of this variable X, since it's a month. In the year 2005. So now I have a function S with the variable X, which is the month, in this year, which is 2005, at a certain department store. I have a store, and the sales is represented by this function during a month X. Represent each statement below, I have here A and B, by an equation involving S or S dash or S prime. Okay, the sales at the end of January reached this number, okay, and were rising at the rate of 1,500 per month. If I'm talking about January, so X will be, what's the value of X? We said that the value of X is the number of the month. Since January is the first month in the year, yes, X will be 1. So here, the sales at the month 1 is, okay, $120,560. Okay, this is the value, or this is the function that described this statement. Okay, and we complete, and we're rising it's rising, so there is a rate of change. When it's rising or dropping, there is a rate of change at a rate of 1,500 per month. So per month, which is January, the rate of change is immediately the derivative of S. Okay, and we're talking about January, so it will be S dash of 1. Okay, the rate of change is 1,500, like this, 1,500 per month. This is how to express this statement using the derivative and the function S dash. Also for the statement B, at the end of March means that X equals to, we said here that X is the number of the month. X is equal to what? March. Yes, it's equal to 3. The sales for this month dropped. Okay, في تناقص في المبيعات هنا. Dropped to this value, which is 80,000, and we're falling about $200 a day. Each day it dropped $200. Okay, it's falling $200 per a day. So if I want to take all the month, I will multiply by 30 for the whole month March. Okay, first I will just express the value of the sales function. The sales of March is 80,000. Okay, this is the amount of sales. And now the amount or the rate of change, which is S dash on the month March, is, notice here that it's falling, so the rate of change here is with minus. Here it's rising, so it's positive, but here is falling, so it's negative. So I multiply by a negative sign. Okay, the rate of change here is decreasing. Here I have $200, but per a day. And the month of March, the March have 30 days. So I have each day 20 multiplied by 30. Okay, this gives me minus $6,000 in the whole month. Okay, 200 per day, so in the whole month will be 6,000 minus 6,000 as a rate of change in the March. Yes, minus 6,000. This is how to translate this problem into the derivative and function using rate of change. This is the solution. Now for this example, it's nothing actually different in this, but only the notation. Okay, notice here that the notation or the name of function, they use t instead of f, and the variable is t. This is the only difference. Okay, so I have to find the first derivative. When they said first derivative, so I have to differentiate once, only one time. If the question was find the second derivative, I have to differentiate twice. So I here find the derivative. I write t dash of t, or write dt, the derivative of t, with respect to the variable t. I can write it in the both way. Okay. Here I will differentiate this, so it will be 2. I take this power down here, multiplied by 1 plus 2t, 2 minus 1, it will be 1, multiplied by the derivative of what inside here, which is 2. The derivative of 1 is 0. Derivative of 2t is 2. Okay? Plus the derivative of t to the power 3 is 3t squared. Okay, notice here this 2 came from the derivative of what inside here. I differentiate what inside the power. I first take the power down, and here I have here 2 minus 1, which is 1. Then multiply with the derivative of what inside in here. Okay, this is equal to 2 multiplied by 1 plus 2t. Sorry, here not 2. 2 multiplied by 2, which is 4. Here I have 4. Plus 3t squared. I can just arrange this polynomial 3t squared plus 8t plus 4. I just distribute 4 inside this bracket and just rearrange. Okay, this is the final answer. Okay. Now for another example, it's the same of the previous one, but in addition, to find the first derivative, I have to find the second derivative. So I have to differentiate twice. I have to find f dash first. After I find it, I have to find f double dash. Okay? First differentiate and second differentiate. First derivative and second derivative. First, notice here that my variable is capital P instead of X. It's just a notation. Okay, this is ready to differentiate, to take the derivative. So f dash of P, or I can write d by dp of f. Okay, I can write it either way. It will be 5. This is 5. I take this power down here, multiplied by 3p plus 1, all to the power 4, multiplied by what inside the brackets, the differentiation of inside the brackets, which is 3. Okay, this is equals to, write it here, 5 multiplied by 3 is 15. Of a 3p plus 1 all to the power 4. Now I will find the second derivative. Find the second derivative. F dash of p is equal to. It's the same thing if I write d square, second derivative, by dp square, okay, of f. Notice here I write 2 on the d and dp square. It's like writing here like that, dp multiplied by d dp. Okay, d by d, it will be d square, and dp 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 square, all applied of f on f. So I will find, this is just a notation. I will find now the second derivative. I differentiate this formula. Okay, this derivative. I differentiate it for the second time. So I multiply 15. I keep 15 here, multiplied by 4, which is the power. I take it down here. Multiplied by 3p plus 1 to the power 4 minus 1. Then multiplied with the derivative of this, which is 3, equal to. Now I multiply these 3 numbers. 15 multiplied by 4, multiplied by 3. 15 multiplied by 4 is 60. 60 multiplied by 3 is 180. Yes, 180. Then multiplied by 3p plus 1 all to the power 3. This is the final result. This is the second derivative of this function. Okay, it's just computation. Okay. Now it's the same. Find d squared by dx squared. So the question is find the second derivative. It's the same. Find the second derivative. F double dash, where f is 3x to the power 4 plus 4x squared. Notice here this notation, a line, and under the line x equals 2. So the question is find the second derivative, then substitute with this value. This is the meaning of this notation. Okay? Find the second derivative at x equals 2. Okay? Find at this value. The question in another word, find f double dash of 2. This is the main question. So first I will find d by dx. Okay, first I will find d by dx of 3x to the power 4 plus 4x squared. I don't substitute now. This is the final step. I will take the derivative now. It will be 12x to the power 3 plus 8x. You know, of course, how to simplify to this. 4 multiplied by 3, 12. X to the power 4 minus 1, which is a 3. Plus 4 multiplied by 2, 8. X to the power 2 minus 1, x to the power 1. This is the first derivative. Now the second derivative, d squared by dx squared of this, which is 3x4 plus 4x squared. It will be the derivative of this one. 12x to the power 3 plus 8x. I differentiate this function. 3 multiplied by 12, it will be 36 x squared plus 8. Now it remains to substitute with 2. Okay, now I will find d squared by dx squared of 3x to the power 4 plus 4x squared at x equals 2. It's equal to this one, the second derivative, 36. Substitute with x equals 2, which is 2 to the power 2 plus 8 equals to 36 multiplied by 4 plus 8, and find the result. What's the result? Try to compute it. 36 multiplied by 4, then add 8. Yes. Which one? Okay. 152. You're sure? Sure? Okay, 152. This is the final result. Just remember to not substitute until you find the second derivative. Okay, only the second derivative I substitute inside it, not the main function, the original function. No, I have to differentiate twice, then substitute in the second derivative. Okay, this is the same result, 152. Okay, here just a new word, instantaneous rate of change. We know what's the rate of change. Rate of change at a point is the derivative at this point. When I said instantaneous, it's actually the immediate rate of change at a point. When I give you a point, the rate of change will be instantaneous. Okay? معدل التغير لما أعطيك نقطة يكون معدل تغير لحظي في هذه اللحظة اللي تكون A. Especially when A is actually the time. Now, to solve this example, suppose that this function f given minus 6 over x minus 6 over x, which is equal to minus 6 multiplied by x to the power minus 1. The question is, what is the instantaneous rate of change? Instead of all this word, I will just find f dash of x. This is the first step. Then the second step, substitute with this value when x equals to 1. So f dash at x equals to 1. So first, I differentiate this function. I rewrite it like that. So f dash of x is minus 6 multiplied by minus 1, which is plus 6 multiplied by x to the power minus 1, which is minus 2, equal to 6 divided by x squared. Just rewriting the function. Now the second step is to substitute f dash of the given value, which is 1, f dash of 1, which is 6 over 1 square, which is 6. Okay, the rate of change is 6. So the rate of change is 6 units per 1 unit for x. Okay, each change in x for 1 unit, it will change 6 units for f or for y. ليش راح السالب؟ أنا هنا عندي سالب minus 6x to the power minus 1. I take this and multiply it here. So I have minus multiplied by minus, which is plus 6. Okay, multiplied by x to the power minus 1, which is minus 2. Okay? Okay, this is the final answer. Okay, I have just have to say the rate of change is 6 units per 1 unit change in x. Okay, 1 unit change in x makes 6 units change in y. This is the rate of change at x equal 1. Okay, the final application and the most important one about the derivative. I have here position. I will define the position function, and I will find the velocity and acceleration. What's the meaning of position? If I have, for example, here a road and I point an x here, an object. Okay, I can find the position, okay, of this x using the position function. I use a position function. I will name it s of t to find the position of any value of x. Instead of x here, I'm talking about time at time t. I'm talking about time t. Okay, so if I want to find a position of an object at a certain time t, I will use the position function. Okay, this is just a definition. The main function given is the position. If I differentiate it, if I take this position function with the variable t, which represents the time, then take the derivative, it will give me the speed that this object move with. I named the speed in the physics and dynamics with velocity. Okay, velocity is the meaning of the speed in the physics. So it will be velocity at the time t. Velocity is the speed. هذه دالة الموضع اللي هي S وهذه دالة السرعة V. Okay. Also, if I differentiate the speed of the the velocity one more time, for example, here S double dash of t, it will be the derivative of the velocity, which is the speed. I will have the acceleration function. Acceleration is the rate of change in the velocity. معدل التغير في السرعة اللي أسميه التسارع, which is A of t, the acceleration of an object at the time t. This is just a notation or just definition. If the question is find the velocity, so I differentiate the position. If the question is find the acceleration, I differentiate the position twice, or if I have the velocity, I differentiate the velocity once. Okay, now for an application here, I will take this example as an application. A toy rocket, I have here a rocket, a toy rocket, fired straight up into the air, has height s of t. Okay, this is the position of the rocket, the position function of the rocket. When I substitute of this t at any time, I will have the position of this rocket at this certain time. Okay, this function gives me the position function, and the unit is feet. After t seconds, the time is measured with the seconds. The first question, what is the rocket's initial velocity? What's the meaning of initial? Initial is the very beginning time, the first time before the movement of the rocket. Notice here, if I have here the ground, this is the ground, and this is the rocket. Okay, it will be moved from the ground, and it will be fired to the air. Okay, it will be like this, the movement of the rocket, and it will hit the ground at the end. Okay, it will get back to the ground at the end. Okay, at the initial velocity means at this point. At this point, there's no time begin. So before this began and has a speed, the time was 0. I will use t equals to 0. Okay, without even given in the question. Initial velocity meaning substituting with t equals to 0. So I will take s of t and take the derivative to find the velocity. I will write velocity first, since the question is find the initial velocity. First, I will find the function of velocity v of t, which is the derivative of s of t, equals to, I will differentiate this function, which is here the derivative of 160 multiplied by t is 160. The derivative of t is 1, minus 2 multiplied by 16, which is 32. 32 multiplied by 2. Okay, this is the velocity function. Now, the initial velocity means at t equals to 0. Here, t equals 0. Equals to 160 minus 32 multiplied by 0. أيوة نعوض بالصفر. We substitute by 0. which is 160 minus 0. This is 160. This is the initial velocity. Okay, even before the movement of the rocket, the initial velocity will be 160, of course, feet per second. Okay, the unit here, it's not necessary, but since it's mentioned here, feet per second. Okay, feet per second. This is the first question. Now, what is the velocity? Again, the velocity after 2 seconds. So it's also velocity. I already find the velocity here. V of t, which is 160 minus 32. 32 of t. And I have to substitute, yes, substitute with 2. T equals 2. V of 2 is 160 minus 32 multiplied by 2, which is 160 minus, this is 64, equals, what's the result here? Will be 6, yes, 96. 96, it's also velocity, so the unit will be feet per second. Okay, this is the velocity at the second 2. Now, the question is, what is the acceleration? Acceleration means I have to differentiate one more time when t equals 2. So I will find the second derivative. For second derivative, I will find a of t, acceleration, which is the derivative of the velocity, v of t. Okay? Yes, the derivative of velocity is here. I take the derivative. The derivative of 160 is 0 minus 32t is minus 32. If I substitute I have here a of 3. I substitute with the 3. There is no variable here, so it will be minus 32. I notice here that the acceleration is constant. So the rate of change in the velocity is constant. It's accelerate and a constant speed. 32, minus 32. This is the acceleration for all values at each time, not only 3 and any other value of the time t. This is the acceleration. Okay. Now also I have 2 more questions about this. At what time? So the question here, what time will the rocket hit the ground? Remember the ground that we mentioned before, and the rocket is moving like this, then hit the ground at this point. Okay. At what time? I want to find t, the time that the rocket hit the ground at this point. Okay, how to find it? Actually, to find it, this means that this is the first position and the time was t equals to 0, and here I want to find the t, the time t. What's the time t for this value here? I have here the position function, which is s of t. Okay, and I have to find the time. Notice here that the speed when the rocket hit the ground will be 0. So I will find the speed, which is s dash, speed, which is velocity, v of t. It will be s dash, as we find it before. It was 160 minus 32t, okay, the speed when it hits the ground will stop, so the speed will be 0. So I will solve this equation for 0. S dash of t equals to 0, so it will be 160 equals to 32t. So t is actually 160 divided by 32. Okay, what's the value here? Someone just divide these numbers and give me the result. 5. Okay, it will be after 5 seconds. Okay. Okay, the speed will be 0 again after 5 seconds. Okay, now for the final question here, at what velocity will the rocket be traveling just as, sorry here, at what time will the rocket hit the ground? I just use the position, not the, here, sorry, we're not using the velocity, we'll use the position. We'll take the position again at 0. Okay, sorry, here. At t, I have here the position. I have here the position at t equal to 0, and I have to find the position, another position at t equals, at what t here. So here also the position will be 0. So I take s of t and make it equal to 0. Okay, so it will be 160 multiplied by t minus 16 t squared equals to 0. So 160t equals to, first I take t as common factor. I will take t as a common factor. It will be 160 minus 16t equals to 0. So either this equal to 0 or 160 minus 16t equals to 0. So if we solve this, it will be t equals to 160, sorry, here 16. 160 over 16, which is 10. So t equals to 0 or t equals 10. I know that t equals 0 is the beginning position. So the second position at t will be 0 at t equals 10. This is the answer. It will be at t equals 0 equals 10. Okay, I have here two answers, but the first answer refers actually to the first position. The second position equals 0 is at t equals to 10, at the 10th second. Okay, after 10 seconds, it will hit the ground again. Now to find the velocity. Okay, we will use now the velocity at this question. At what velocity will the rocket be traveling just as smashes into the ground? Okay, now again smashes into the ground. We know now the time which the rocket hit the ground, which is t equals to 10. And I have the velocity v of t, which was 160 minus 16, not 16, 32 minus 32t, and I have to substitute with the second 10 to find the velocity at the 10th second, to find the velocity at that time. It will be 160 minus 32 multiplied by 10. Yes, I replace it here. I just divide by 16. It will be 160 minus 320. The result will be with minus. Minus how much? Yes, minus 160. Notice here that I have a minus sign here. It refers to the direction of the object. Here it's going down, okay? Going down like that, or clockwise باتجاه عقارب الساعة أو إنه يتجه إلى الأسفل. For that I have this sign, okay? It's from the result immediately, but the repetition تفسير هذه العلامة it's the direction of the object. It's going down. Okay, so the velocity at the crash time or smash time, which is t equals to 10, is minus 160. It's actually equals to the first velocity, the first at t equal to 0, which is 160. But this was positive since it's going up, and we just found it was negative since it's going down. This is the only difference. Okay, this was that was the final example. We finished this this tutorial and this lecture. You can leave if you want. أيوة بالأخير استعملنا دالة المشتقة. We use the derivative to find the velocity. دالة المشتقة اللي هي الvelocity. أوكي راح أرجع لل NDE. This one. The question here, at what time will the rocket hit the ground? Okay, the rocket will begin from here. I know the time and the position, which is 0 for both, t equal to 0 and s equal to 0. I want to find the position. No, I know the position here is also 0, but I want to know the time, at what time. So here the question is all about the position. So it was wrong to use the velocity. The correct answer is to use the position function. I want to use, I know here the position is 0, so I want to find the time at this position. Okay, this is how, this is why I used the position function. Yes, we will talk now about the quiz. Just, I will stop the recording. Okay. Okay, we finished the lecture now. You can leave if you have another lecture or you have another thing to do. بالنسبة للكويز بكرة عندكم كويز بكرة صح؟ اليوم 9 بكرة 10. بكرة الكويز which is 10th of February. I sent an email about it. 10th of February. Okay. أي واجب؟ في عندكم واجب؟ Tomorrow will be the quiz. Be ready at 7 p.m. which is 19 p.m. The duration of the quiz, as I know, will be only 15 minutes. Be ready. Okay. If you're talking about TMA is for you. You have to try it by yourselves. It's not it's not difficult actually. اوكي هذا تدريب لكم TMA مطلوب من الطالب فقط انه يحاول فيه. اوكي yes, multiple choice for the quiz tomorrow, quiz 1 all will be multiple choice question. الاختبار 8 ولا 7؟ في الموقع مكتوب 7 كان ولا 8؟ أنا أرسلت لكم إيميل صح؟ Yes, sorry here your M129 it will be at 20. Yes, I remembered. 20 p.m. So be ready. It will be only 15 minutes. أرسلت إيميل، أرسلته بالLMS يعني المفروض إنه وصل لجميع الطلاب. Check on your university email. الكويز على ما أعتقد 6 questions. 6 questions. Each question out of 1 marks. راح يكون الكويز out of 6. Okay, 6 out of 6. 6 أسئلة كل سؤال عليه درجة واحدة. طبعا there is no make up for this quiz. إن شاء الله إنه راح يكون بسيط. لحد الحين ما أخذته شيء صعب. راح يكون only in tutorial 1. فقط في الفانكشن. الديريفاتيف اللي تو درسناها وبدأنا فيها الأسبوع اللي فات مش مطلوبة عليكم، مطلوبة في الكويز الثاني. الكويز الأول only on functions tutorial 1. اوكي only tutorial 1 اللي أرسلت لكم اللينكس only on tutorial 1. And I think after 2 weeks, maybe 1 or 2 weeks, it will be quiz number 2. Quiz number 2 will be on tutorial 2 about the derivatives. Okay. Do you have any question? I will just unmute for you. You have a question, you can use the mic. تقدر تستخدم المايك. تذاكروا السلايد. الكتاب هي طبعا كل السلايد اللي موجودة عندكم مأخوذة من الكتاب، بس مش كل مواضيع الكتاب مطلوبة. ادرسوا السلايد وممكن تتعمقوا أكثر أمثلة إضافية من الكتاب، بس لا تدرسوا أشياء أو مواضيع مش مذكورة عندكم بالسلايد. فقط المواضيع المذكورة بالسلايد شوفوا عليها أمثلة زيادة بالكتاب وتدربوا عليها. ممكن تتدربوا على الإكسرسايزز. Only the slide. You can use the book beside the slide, but the main thing is the slides. أكيد عليه درجات TMA 20%، عليه 20 درجة. اوكي الأهم إن يكون عندكم كلكم السلايدز موجودة عندكم على LMS، اعملوا لها داونلود وادرسوا منها. بالإضافة إلى الريكوردد ليكتشر I already sent it to your emails. Just check your emails.
دكتورة؟
أيوة.
السلام عليكم.
وعليكم السلام.
الله يسعدك، بس في سؤال بخصوص الواجب أمس كنت أحله، وفي سؤال شوية يعني ما فهمته أو ما فهمت فكرته، يعني مو عارفة إنه طريقة صيغة السؤال مو إنه طريقة الحل، فمعلش تقدري بس تفتحي شوية؟
أنت قصدك اللي بالTMA؟
يس.
احتمال تكونوا ما أخذتوا الموضوع.
لا أخذناه بخصوص هو التوتوريال الأول.
متأكدة؟
السؤال الثاني في TMA التوتوريال
طيب.
الأول أتوقع.
اوكي بس لحظة أشوف TMA. أتوقع إني عملت له داونلود. ثواني بس. اوكي اوكي. اي سؤال اللي كان عندك؟
السؤال الثاني.
سؤال